So in this video we're going to cover the last page, converting degrees to radians. And so we're going to take 30 degrees and we're going to multiply that by pi over 180 degrees and we're going to get radians. So pi radians over 180 degrees. Now the degrees, if you think about this, the degrees cancel. 30 goes into 30 once, 30 divides evenly into 180 6 times. So 30 degrees is pi over 6 radians. And that's A. So if you know your unit circle, though, I mean, let's not do more work than we need to here. We know that the unit circle, that's 30 degrees. Well, that's pi over 6 radians, so you should know that anyway. This is only this conversion process really is only for numbers like, we don't need to use 120, negative 60, 270. We already know 270 is 3 pi over 2. I mean, don't do more work than you need to. 120, that's up here. 90 and 120, so pi over 3, 2 pi over 3, so that's 2 pi over 3 radians. Negative 60, well, that's down here. Negative 60 is negative pi over 3 radians. But the 104, let's do that one. So the 104 degrees, if we multiply by pi over 180, and I always remember this because I remember either it's going to be pi over 180 or 180 over pi. The way I remember this is that usually when I go from degrees to radians, I want to get a pi in there. And so the pi stays on top. When I want to go from radians to degrees, I want to get rid of the pi. So like, let's say we do with like 5 pi over 2 radians. If I multiply by 180 over pi, I'm going to get rid of the pi's. If I did pi over 180 here, I'd get 5 pi squared over 360, and that you don't usually see a pi squared. It doesn't mean you can't, but you don't usually see a pi squared when you're dealing with degrees. Anyway, 104 over 180, okay, that's pleasant. So let's see, 26 goes into there 4 times. That means that 13 goes in 8 times, right? 13 times 8, 26 times 4, 13 times 8. So 8 there, 13 times 8, no, that's not what I meant. 13 there, 8 times 13, 8 times, oh, that's beautiful. I did try to do too much in my head. I was going to pause it, but I don't have another copy of this, so you can just hear my mistakes. So scratch that. I'm going to go with 4 goes into 26. So 4 goes into that 26 times. 4 goes into that 45 times. I guess I should have stopped there. So that's 26 pi over 45. Yeah, 3 doesn't go into 26, and 2 and 22 and 13. Yep, that's it. So 26 pi over 45. Sorry for that mess up there. I'm only human. Convert each angle in radians to degrees, and so let's do that 5 pi over 2. So 5 pi over 2, we're going to multiply by 180 over pi. The pi's cancel. And 2 goes into 180 90 times. And 90 times 5, 9 times 5 is 45. And with an extra 0, 450 degrees. Of course we could have done that anyway. 5 pi over 2 is 1, 2, 3, 4. 5 pi over 2 is 360 plus 90, 450 degrees. But that's the idea. If you want to convert radians to degrees or degrees to radians, you have an easy formula to do that. And if you know your unit circle better, if you know it without having to think about it too much, then you don't have to multiply through by the pi over 180 or 180 over pi. All right, enough rambling by me. Let's do the last thing here. We've got area of a sector. And area of a sector, we have a formula. And I'd like to show you where the formula comes from. If we take the area of a circle, okay, so we know the area of the circle is pi r squared, and by taking the area of the circle pi r squared, and let's just draw just a random angle here. So we have an angle here like that, and we know that that angle is a part of the circle. So we're talking about a sector, by the way. That sector is this like piece of the pie. So one piece of the pie. The entire pie is pi r squared, interestingly enough. So no pun intended. So we have a fraction, so area of a sector is equal to the fraction pi over 2 pi times pi r squared. So the fraction of the pi, boy, there's too many pi's here. So we have pi divided by pi, that goes away, and what we get here is pi r or theta r squared over 2, and there's our theta, our r squared, and there's our 1/2. So area of a sector is 1/2 r squared theta. This is an important formula, the other formula that you just have to remember. And the theta, important here, must be, write this down, important, must be in radians. Radians only. You can't use degrees there. So here we have degrees, we got to convert to radians. Find the area of a sector of a circle, radius 5 feet. So let's draw a picture of that. So we have a 5-foot radius formed by an angle of 60 degrees. So here's 60 degrees. And we're trying to find the area of that sector right there. So now it's not very easy to see the 60 or the 5, but nevertheless we know we have 5 feet. Well, let's put it down here. 5 feet and then 60 degrees. But 60 degrees, remember, equals pi over 3 radians. And so the area, very simple, then just go ahead and plug in the 5. Plug in the pi over 3. And we have 25 pi over 6. So that's the area of the sector, 25 pi over 6. And we are done.